Okay guys, we're going to start chapter 10. So here is 10.1. Go ahead and try the warm-up by yourself. Put me on pause and then resume when you are finished. Go ahead, hit pause. Okay, hopefully you actually tried this by yourself, because otherwise you're doing yourself a disservice if you're just waiting for me to walk you through it. It says find the roots of the equation x squared is equal to 30 minus 13x. The trick is to know that this is a quadratic equation, which means that you want to get it set equal to 0 unless you're doing completing the square. But I'm going to go ahead and try to see if it is factorable. When you set it equal to 0, try to make sure your x squared term is positive, so that means I'm going to move these two terms over to the left. So I'm going to subtract 30 and I'm going to add 13x to both sides. That cancels, I'm left with putting them in standard order. X squared plus 13x is equal to, or minus 30 is equal to 0. There is no GCF. If it's factorable, I'll do it that way. If not, we could go quadratic formula or possibly completing the square, which wouldn't be actually fun because the b term is odd. We need different signs to get to a negative. My factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. I know that I'm going to subtract, so I need to know which ones do I subtract to get to 13, and that would be the 2 and the 15. 13 has to be a positive, so put the 15 with the positive and the 2 with the negative. It's fully factored. Now set each equal to 0. It's the first binomial factor and the second one. Subtracting 15 from both sides, that's going to give me x is equal to negative 15. Add 2 to both sides. That gives me x is equal to positive 2. Make sure, I'm not going to go ahead and do that because I'm going to be cut short in time, but make sure you guys know that you have to go through the double check because you have two answers, two roots. Okay, also don't forget that if you were to ever graph this, the two roots would cross the x-axis at negative 15 and positive 2, and the parabola would open up because a is positive. So just a reminder. Alright, let's go ahead and start section 10.1, which is the Pythagorean theorem. This should be a pretty good review for you guys because you have done this in middle school. The Pythagorean theorem only applies to right triangles. It will not apply to anything else, not even triangles that are not right. So it has to be a right triangle for you to be able to use this. Okay? In the diagram, you will notice that they labeled the A and the B, which are the legs, and the C, which is the longest side, is the hypotenuse. Okay, and that's opposite the 90-degree angle. You can interchange the A and the B, but the C always has to be the longest side opposite that 90 degree. It's been proven that A squared plus B squared is equal to C squared, so the square of each legs added together will equal the square of the hypotenuse. That is what the Pythagorean theorem tells us. Here we're finding the hypotenuse. It says, what is the length of the hypotenuse of a right triangle? The lengths of 9 and 12. So really, I'm looking at a right triangle. Legs are 9 and 12, and they want me to find the hypotenuse. As soon as they tell me it's the right triangle, and I'm dealing with the sides, not the angles, I know that I can use the Pythagorean theorem. A squared plus B squared is equal to C squared. Substituting in your legs into A and B, does not matter which one you put for the A or the B. 9 squared is 81. 12 squared is 144. And 81 plus 144 is 225. Equals C squared. The inverse of squaring, you have to get C by itself, so you have to get rid of that, would be square rooting. Make sure you do it to all terms. I'm going to switch my sides here. The square root of 225 is plus and minus 15. Know that negative 15 would not be a possible dimension of a triangle, so therefore we will take the positive answer that 15 centimeters is the hypotenuse. Okay, so we X out or eliminate the negative 15 choice. Finding the leg, here they gave us the picture. They told us that the hypotenuse is 15, one of the legs is 12, and they want us to find the other leg. Because it's a right triangle, and I know that because of this box right here, or they will tell you that, I am allowed to use the Pythagorean theorem. Otherwise, I would not be allowed to use it. The leg is 12, so make sure you put that in the right spot, and the 15 is the C. 12 squared is equal to 144, and 15 squared is equal to 225. Uh, 225. Subtract 144 from both sides so that we can get a squared by itself. You end up with 81. The inverse of squaring would be to square root. That will cancel. And you end up with a is equal to plus or minus 9. Now, again, you have two answers, two roots of 9 and negative 9. The side cannot be a negative, so therefore we will say the leg is 9. And because they didn't give me a unit of measurement, I'll just call it 9 units. I think, yeah, this is the last screen. Is it a right triangle or not? A, could the lengths 20, 47, and 52 millimeters be the side lengths of a right triangle? Explain. So if these were of a right triangle, the right sides, then we would know that the Pythagorean theorem would work. So we can actually substitute this into the Pythagorean theorem, make sure that the 52, which is the largest side, is substituted in as your C, and if it works for the Pythagorean theorem, then we know it is a right triangle. If it doesn't work, then we can say it is not a right triangle. 20 squared is equal to 400. 47 squared is equal to 2209. And 52 squared is equal to 2704. 400 plus 2209 comes out to 2609, which is not equal to 2704. So therefore, it is not a right triangle since the Pythagorean theorem did not work. If A, B, and C satisfy the equation a squared plus b squared equals c squared, are 2a, 2b, and 2c also possible side lengths of this right triangle? Well, let's go ahead and substitute it in. So they're telling us, here's our Pythagorean theorem, what if we let that be 2a, 2b, and 2c? So I'm going to substitute 2a in to my a, 2b in to my b, and 2c in to my c. When you square this, this means 2a times 2a, which is 4a squared. 2b times 2b is 4b squared. And 2c times 2c is 4c squared. Notice how they all have a common coefficient of 4. If you divide everything by 4, which you're allowed to do as long as you do it to all the terms, then these guys would all cancel. And you would end up with a squared plus b squared equals c squared, which comes back to the original Pythagorean theorem, and so therefore, yes, it's true by the proof above. Okay? And that takes care of 10.1.